This is Edexcel Secure Mock 3 Paper 1H. Question 1. 3 to the power 5 times 3 to the power 4 divided by 3 to the power 2. Well, 3 to the power 5 just means 3 times 3 times 3 times 3 times 3. So that's 3 to the power 5. And 3 to the power 4 is another 4 lots of 3 multiplied together. Altogether at the top, we've got 3 to the power of 9. So the shortcut for that is just to add the powers. We're dividing that by 3 squared, or 3 times 3. So if we're dividing by 3 twice, that will cancel out with 2 of the 3's on the top line. So dividing by 3 squared, the shortcut is to subtract the powers. So we'll have 3 to the power of 7. Part B, anything to the power of 0 is 1. The reason for this, if we start off with 12 squared, which is 144, 12 to the power 1 would just be 12. So we have divided by 12 to get to here. So if we divide by 12 again, that gives us 1. So you can think about, instead of multiplying up by 12, you can think of it as dividing down by 12. 3 to the power of minus 2, the negative in an indice means put it as 1 over, or find the reciprocal. So it means 1 over 3 squared, which is 1 over 9. Question 2. The diagram shows a fish tank in the shape of a cuboid. The dimensions of the cuboid are 50 by 32 by 20. The tank is 3/4 full of water and sand. The ratio of the volume of water to the volume of sand is 5 to 1. Work out the number of litres of water in the tank. So first of all, we've got, for the water, we've got this dimension, which is 50. We've got this dimension, which is 20. We just need this dimension here. Now we know that this distance here is 3/4 of the full distance, the 32. So the first thing we need to do is find 3/4 of 32. Now, to do that, we divide by the bottom and times by the top. So 32 divided by 4 is 8, and times by 3 is 24 centimetres. So this full distance here is 24 centimetres. We now just need the distance to here. So this distance here is the 24 centimetres. It's split in the ratio of 5 to 1. So 5 to 1 is 6 parts. So we need to do 24 divided by 6, which is 4. So the water will be times by 5 lots of 4, which is 20, and the sand will be 1 lot of 4, which is 4. So this distance here will be 4, and this distance here will be 20. So to work out the volume of water now, we can just do length times width times height, which is 50 times 20 times 20. 5 times 2 is 10, times 2 is 20, and then add your 3 zeros, that's 20,000 centimetres cubed. Now it asks for the volume in litres. Now we need to know that 1 litre is 1,000 millilitres, and 1 millilitre is the same as a centimetre cubed, so that's the same as 1,000 centimetres cubed. So we need to do 20,000 divided by 1,000, which is 20 litres. Question 3. Betty, in a sale, the price of a cooker is reduced by 50%. At the end of the sale price of the cooker is increased by 50%. Betty says the cooker is now the same price as it was before the sale. Is Betty correct? Well, Betty's not correct. So what we need to look at here is an example to show that Betty's incorrect. So, for example, if the cooker was originally £100, to knock off 50%, you'd multiply by 0.5. So 0.5 times 100 would be £50. And then to add 50% back on, it times by 1.5. So 50 times 1.5 would be £75. So the best way to explain whether someone's correct or not is to show a good example. Question 4. It says, here is a kite. All the angles are measured in degrees. Work out the value of y. Well, if this is a kite, this length and this length are equal. This length and this length are equal, which means that these two angles here are equal as well. So we can use these two angles being equal, so put them equal to each other, to work out the value of x. So if we expand the brackets, that will be 5x minus 50 equals 3x plus 10. To solve this equation, we subtract the least amount of x off both sides. So we're going to take 3x off this side, and we're going to take 3x off this side, which will mean that 2x minus 50 is equal to 10. Then we're going to add the 50 to both sides to get rid of this minus 50, will give us 2x is equal to 60. So x must be 30. Once we've got x equals 30, we can now work out the value of this. So 3 times 30 add 10. 3 times 30 is 90, add 10 is 100. And this should be the same. We don't really need to work it out, but just in case, we do 30 take away 10 is 20, times by 5 would be 100, so that would be the same again. We know that a four-sided shape, the angle should add up to 360. So we do 360, take away these three angles that we've already got, so 110, add 100, add 100, and that would leave us with 50 degrees for y. So y equals 50 degrees. Question 5. Solve the simultaneous equations 3x minus 2y equals minus 5 and 2x minus 4y equals 2. Straight away we've got a lot of negatives in this, so you've got to be really careful with your negatives. It's something you should really practice if you struggle with these. So the first thing I'm going to do is I'm going to multiply the first one by 2 and the second one by 3 so that we get the same amount of x's. So to multiply the first one by 2, I would get 6x minus 4y equals minus 10. And multiplying the second one by 3, I would have 6x's minus 12y's equals 6. From here, we're going to subtract these two away from each other because 6x take away 6x will give me no x's, so that's the whole point of doing this. The difficulty here is with negatives. So we started off with minus 4y's or negative 4y's. We're taking away another negative number. So taking away a negative is like adding. So we're starting at minus 4 and we're adding on 12, which will get us up to plus 8y's. We then started off with a negative again, minus 10. We're going to take off 6 and that will give us minus 16 or negative 16. So divide by 8 and we get y equals minus 2. So we've got y to be minus 2. Now we've got y, we can substitute that in. I'm going to substitute it into the second equation, purely because the first equation has a negative answer, which we tend not to be very good with negatives. So I'm going to substitute it into the second one. So we've got 2x, take away 4 lots of minus 2, equals 2. So expanding those, we've got 2x, take away, and 4 lots of minus 2 is minus 8. So again, we're subtracting a negative here, equals 2. Subtracting a negative, like we said earlier, is the same as adding. Sorry, that should be 8, equals 2. So we have, take the 8 off both sides, we have 2x equals minus 6, and we have x would be minus 3. Question 6. Shown is a regular octagon. Regular means that all sides are the same. It says ADJ is a straight line, so this line here is straight, and it says that angle BAD is equal to CDA, so these two angles are equal to each other. Show that CDJ, so CDJ is 135 degrees. Now, because we are given that that's 135 degrees and we try to show it, we cannot use that in our working out. We've got to use something else to show that that is 135. So the easiest thing that we know to do with regular shapes is that all external angles add up to 360. So if we carry a straight side on like this angle here, which is an external angle, would be 360 divided by the number of sides. So 360 divided by 8, which is 45. That means that this must be 135, and because this is a regular shape, this must also be 135. We also know that this is a four-sided shape, and they're up to 360. So 135 add 135 is 270. So 360 minus 270 is 90 degrees, and these two are equal. So 90 divided by 2 would be 45 degrees each. So this would be 45 and this would be 45. It's vital that we show this working out here so that they know that you're not using the original 135. Once we've got that, we know that angles on a straight line add up to 180. So 180 minus 45 equals 135 degrees for angle CDJ. So you've just got to show that it's 135 without using the fact that you were given that it was 135. Question 7. Right, 0.00549 in standard form. Well, we need to divide this by 10, 1, 2, 3 times to get it as a whole number. So that would be 5.49 multiplied by 10 to the minus 3. So the minus 3 means divide by 10 rather than multiply by 10. Second one, it says find the value of 8 times 10 to the power of 3 squared. So this would mean 8 times 10 to the power of 3 times 8 times 10 to the power of 3. Now 8 times 8 is 64, and 10 times 10 to the power of 3 times 10 to the power of 3 would be 10 to the power of 6, using the shortcut that we add the indices. And then to put this back in standard form, it needs to be a number between 1 and 10, so this would be 6.4 times 10 to the power of 7. It says find the value of 7.6 times 10 to the 5, add 8.7 times 10 to the 4, and again give your answer in standard form. So 7.6 times 10 to the 5 is 7, 6, 1, 2, 3, 4 zeros, and 8.7 times 10 to the 4 would be 8, 7 and 3 zeros. And we need to add those together. So we've got 0, 0 and 0. This would be a 7. 6 add 8 is 14, so 4 down carry 1. And 7 add 1 is 8. So we've got 847,000. Now to put that back into standard form, it needs to be a number between 1 and 10, so 8.47 times 10 to the power of 5. Question 8. 20 men, 10 women and 10 children are in a competition. The mean score for the women is 15.6 and the mean score for the children is 9.2. Kevin says that the mean score for all 40 people is 11.2. Work out the men's mean score. So to do this, work out the mean means to add them all up and divide by how many there are. Once we've added them up, we can never get back to the original data, but we can get back to the total by multiplying by how many people there were. So if there were 10 women, those 10 women must have had a total of 156 points in this competition. For the children, again there were 10 children, so we multiply that by 10, they must have had a total of 92 points in this competition. Now if we add those two together, we get 248. So in total, all 40 people, so 11.2 times 40, would be 448. So the total points for all the men, children and women would be 448, and just for the women and children it would be 248. So we take these away from each other, we end up that the men must have had a score of 200. Now there were 20 men, so we need to do 200 divided by 20, which will give me an answer of 10 for the men. It says, Kevin is wrong. The mean score for all 40 people was actually 11.15. Now the key here is that 11.15 is a little bit smaller than 11.2. How does this affect the score for the men? So to do this we just need to write a very short sentence just saying that the men's mean would be reduced, because if the overall mean has been reduced and the children's and women's stays the same, then it must have been the men's that was lower, not the women's or the children's. Question 9. The stem and leaf diagram shows the ages in years of 25 people. So it's really important, we don't need to count up, we've got 25 people. On the grid, draw a box plot for this information. Well, a box plot starts off with the minimum value, which would be at 17, so we need to draw a line at 17. The maximum value, which would be at 41, so we need to draw a line at 41. And then we need the median, the lower quartile and the upper quartile. Now if there's 25 people, we would be after the 13th person to be in the middle, because that would mean there were 12 before them and 12 after them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 13th person is 28 years old. So we're going to put the median at 28. Below this then, we've got 12 numbers. So if we can split that into 6 and 6, we've got 1, 2, 3, 4, 5, 6. So the lower quartile must be just between 22 and 24. So the lower quartile is at 23. Again, above the median, we've got 12 numbers. So 1, 2, 3, 4, 5, 6. Again, and 6 on the other side. That means that the upper quartile must be at 32.5. So really carefully draw in halfway between 32 and 33. And then the box plot is just drawn around and you connect the maximum and minimum values with the box. It says, one of these people is chosen at random. What is the probability that the person is 30 years or older? So we can go back to our stem and leaf diagram. There's a 30-year-old, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these people were 30 or older, and there are 25 altogether. Now it doesn't ask for it in its simplest form, but I always like to do it as a good habit. That would be 2/5. It says the group frequency table gives information of the ages of different groups of people. Anne drew the cumulative frequency table for this information. The cumulative frequency table is not correct. Write down one thing that is wrong with the table. Well, first of all, the thing that I notice here is that with a cumulative frequency table, the first number should always be a 0, always be the minimum value. It could be other than 0, but it should always be the same. So the class intervals should all start with a minimum value, which in this case would be 0. Question 10. It says AB equals 3, 2 and BC is minus 1, 4. AB is drawn on the diagram for you. On the grid, draw BC. So the really important thing is, we're starting at B, so that's the point B, and BC is the vector -1, 4, so that means to go left 1 and up 4, so that will go to here. So this is where C is, and we will draw that in up to there. It says AD is AB, so we're starting at A, so to get from A to D, we go along AB, and then we take off BC. So the opposite of BC would be to go right 1 and down 4. So that would end up over here. So point D would just be here. Question 11. P is inversely proportional to the square root of M. So I'm going to write that down straight away. So P is proportional to the inverse of the square root of M. So really important we get that written down first. It says when P equals 10 and M equals 1/4, work out the value of M when P equals 2. So first of all, we're going to have to put in the constant of proportionality. So P is equal to K over the square root of M. If we put our values into that, we've got P is 10 when M is 1/4. Now the square root of 1/4 is 1/2, because 1/2 times 1/2 is 1/4. So we're divided by 1/2 there, so if we multiply the other side by 1/2, so 10 times 1/2 would equal K, and 1/2 of 10 is just 5, so K equals 5. So our formula that we're going to use is P equals 5 over root M. We are told that when P equals 2, we've got to work out M. So we put that P equals 2 is equal to 5 over the square root of M. To rearrange this, we're going to take the M up here and the 2 back down here. So we have the square root of M is equal to 5 over 2. And then to square that, so 5 over 2 is the same as 2.5. And to find out M, we need to square that, so 2.5 squared would be 6.25. Question 12. The region R shown, shaded on the diagram, is the region between two circles with the same centre. The outer circle has radius 2n plus 6, the inner circle has radius n minus 1. All measurements are in centimetres, and the area of R is greater than the area of the circle of radius n plus 13, where n is an integer. Find the least possible value of n. Show you're working. So, we're working out with the area of a circle here. So, the area of the big circle is going to be pi r squared, so pi times 2n plus 6 squared. And it says we need to subtract pi times n minus 1 squared to get the area of the region. So we're going to subtract the smaller circle just to get the shaded region. And that is greater than the area of a circle with radius n plus 13. So we need to do is greater than pi times r squared, so pi times n plus 13 squared. Sorry, squared. So we notice that each one's got a pi, so if we divide through by pi, we can just totally get rid of pi from the beginning. So as soon as we divide through by the same number all the way through, that should be absolutely fine. So that would leave us with 2n plus 6 squared, take away n minus 1 squared, would be greater than n plus 13 squared. So we need to expand all these out and then simplify it through. So the first brackets expanded out would be 4n squared plus 24n. Again, you could do this the full way if you need to do that, but I'm just going to do it all in one go. And we're going to take away from that n minus 1 squared, so that would be n squared minus 2n plus 1. Notice I've put it in brackets because we're going to subtract that in a minute, so we need to make sure that we know what we're doing with that. And that would be greater than, and this would be n squared plus 26n plus 169. So, simplifying through, first of all, we can put we've got 4n squared take away n squared, which will give us 3n squared on this side. We've got 24n's subtract minus 2n, so that'd be like adding. So we've got plus 26n's. And 36 take away plus 1 would be the same as 35. So that's the left hand side simplified. And that is still greater than n squared plus 26n plus 169. Then, notice we've got 26n on both sides, so again we can cancel the 26n's out. We can subtract this n squared off both sides, so we end up with 2n squareds. And we could subtract the 169 off, and we could subtract the 35 off the 169, and that would give us 134. So we've got the 2n squared must be greater than 134. If we divide by 2, we've got that n squared must be greater than 67. So n is going to be greater than, now we know that the square root of 64 is 8, so it's going to be 8 point something, okay? But we know that n must be greater than that, we know it's an integer, it must be a whole number, so that n must be at least 9. Question 13. The graph shows the temperature T of the coffee in a cup at time t seconds. Find an estimate for the gradient of the graph at 5 minutes. So to work out the gradient of the graph, we need to make sure that we draw a nice tangent at 5. So at 5 minutes is just there. So using a ruler, you will draw from here and touch it just as you can there, like that, as close as you can, just touch it with the tangent. So you'll notice that this goes from 0 up to 48, and this goes from 0 up to 16. So the gradient is the difference in y divided by the difference in x, which is 48 divided by 16, which would be 3. Now this is a negative gradient, so this would be negative 3 for the gradient. It says, explain what the gradient represents. Now basically you've got temperature divided by time, so it's a decrease in temperature over time, which is just the rate of change of temperature of the coffee. Question 14. It says a particle P is moving in a straight line. O is a fixed point on the straight line. The distance s meters of P from O at time t seconds is given by the equation s equals 80t minus 5t squared. Use algebra to find the greatest distance of P from O between 0 and 16. Now the really important bit there is that it says using algebra. So you can use the fact that this is symmetrical and do it using a bit of common sense really, but you've got to use algebra. So the first thing I'm going to do is I'm going to pull out a factor from this. So we notice that 5 goes into both of these, and I'm going to actually pull out minus 5. The reason why I'm going to do that is that that would mean that this would come back to a plus t squared in there. So, and that would be minus 16t. So if I factorise out minus 5, it gives me that. I'm going to then complete the square for this t squared minus 16t. So to do that, we half the amount of t's, so that would be 8. So this would be the same as t minus 8 squared. T minus 8 squared will give us t squared minus 16t's, but plus 64. So I need to take 64 off the end to complete that square. So the turning point of this would be when this bracket is equal to 0. So the turning point is when t would be 8, because 8 take away 8 would be 0. So the turning point is at 8. So now we know the time at which the turning point occurs, we need to substitute that in to find the distance. So the distance s is given as 80t, so 80 times 8, take away 5 lots of 8 squared. So 80 times 8 is 640, and take away 5 lots of 64, which is 320. So the distance would be 320 metres. Question 15. There are only n red balls and n plus 1 blue balls in a bag. Shamsa takes at random 2 balls from the bag. Show the probability that both balls are the same colour is n over 2n plus 1. Well, I'm going to split this up. I'm going to do red first and then I'm going to do blue second. Now because we're not bothered about whether it's red or blue, we can add these together. However, we do want the first one to be red, if we want them both to be red. So there are n reds, and altogether n plus 1 is 2n plus 1. And we're going to multiply that by, because we want a second red, n minus 1, because we've already taken 1 red out, so there'll be 1 less red, over 2n, because there were 2n plus 1 before, so if you've taken 1 out, there'll now only be 2n. And we're going to add to that the probability of getting a blue, which is n plus 1, over how many there were in the bag, 2n plus 1. And we're going to multiply the blue by the second blue. Again, there'll be 1 less blue, so that would just be n, and there'll be 1 less in the bag, so that would just be 2n. If we expand these out, we just do top times top, so we'd have n squared minus n. And on the bottom, we only need a common denominator. We can see that we're going to have a common denominator here. So I'm just going to leave that as 2n brackets 2n plus 1, rather than expanding it out. And we're going to add to that the tops of these multiplied together. So again, we'd have n squared plus n over 2n brackets 2n plus 1. Now, to add these two together, because we've got a common denominator, we would just have n squared plus n squared is 2n squared, and minus n plus n would be nothing, and that would all be over 2n brackets 2n plus 1. Now, to simplify that, I can do 2 divided by 2, and I could do an n divided by one of these n's, which would leave me with n over 2n plus 1, which is exactly what it asks me to show. Question 16. Here are two solid spheres, A and B. Sphere A is made of gold and sphere B is made of silver. Sphere A has a radius of 2 centimetres and B has a radius of 3 centimetres. Gold has a density of 19,000 kilograms per metre cubed and silver 10,000 kilograms per metre cubed. Which sphere has the greater mass? Well, first of all, these distances are in centimetres and we want to be working in grams really. So the first thing I'm going to do is convert these two to grams per centimetre cubed. So there are 1,000 grams in a kilogram, so I'm going to times by 1,000, and it's converted to centimetres cubed. You want to divide by 100 3 times because it's cubed, and that will give me 19 grams per centimetre cubed. And again, the same with this one, we'll divide by all of this, and that will give us 10 grams per centimetre cubed. Now, the volume of A, I'm going to split these up. I'm going to do A and B separately. So the volume of A, we're given that the volume of a sphere here is 4/3 pi r cubed. So we're going to do 4/3 times pi times 2 cubed. And over here, we're going to do 4/3 times pi times 3 cubed. Now, to get the actual mass, we need to multiply that by the density as well. So we're going to multiply this one by 19, and we're going to multiply this one by 10 to get the masses. Now, because we're only after comparing the masses, we can just divide through this. We're only after comparing after the actual mass. So I can get rid of the 4/3 pi on both sides, because I'm only after comparing whether one's bigger or smaller. I don't actually need the actual mass. So 2 cubed is 8 times 19, and on this side 3 cubed is 27 times 10. So 8 times 19 is 152, and 27 times 10 is 270. So even though this isn't the actual masses, we do know that sphere B must have the greater mass. So sphere B has the greater mass. Cancelling out by the 4/3 pi just means that we don't have to do any really difficult calculations, because we're only after comparative figure, not the actual figure itself. Question 17. It says x squared minus 9y squared equals 0, where x is greater than 0 and y is greater than 0. Work out the ratio of x to y. Well, if I rearrange this then, we would have x squared is equal to 9y squared, and if we square root both sides, we would have x is equal to 3 lots of y. So to get to x, you have to multiply y by 3. That means that x must be 3 times bigger. So x would be 3 parts and y would be 1 part. It's really important you get the numbers the right way around now. Part B, simplify fully. 3 minus 4x minus 4x squared all over 2x squared minus 7x plus 3. So on the top, we would factorise that. We know it's going to have to be a 3 and a 1 in the brackets. And to get a 3 and a 1, and to get the 4x's, we're going to have 2 x's in here and 2 x in here. Otherwise, it'll have too big a difference to have those out. Now, 3 times 1 is a 3, so that gives us that. 3 times 2 x's gives us 6 x's, and 2 times x gives us 2 x's. So I want this to be a positive, and I want this to be a negative, because then we'd end up with 6 x's, 6x squared to take away 2x squared, which will give us the 4x squared. On the bottom, we have got, again, we're going to have 2x and x in here to get the 2x squared, and to get the 3 we have to have a 3 and a 1, but to get the minus 7x's I want the 3 across from the 2, so I end up with 6x's and the 1 on this side, and because we want a minus 7x's, both of these are going to have to be negative. Now you'll notice that neither of these have the same thing in them. However, this is the opposite of this. So if I multiply the bottom through by minus 1, then that would give us 3 plus 2x and 1 minus 2x on the top. And on the bottom, if I multiply both by minus 1, it will cancel each other out. And that will give us 1 minus 2x, and this would be 3 minus x. So because I've changed both of these into, multiplied both of these by minus 1, that will cancel each other out, because minus 1 times minus 1 is plus 1. So then this cancels out with this, and we're left with 3 plus 2x over 3 minus x. Question 18. The graph of y equals f of x is shown on the grid. On the grid, sketch the graph of y equals f of x minus 1. Well, if we've got f of x minus 1, this would mean that the graph will move right 1, because we'll get the same value for y when x is 1 earlier. So we're going to move it across. The top point would go to here. It's really important that you plot all the points that cross a square. So that would go to there, and this one would go to there. And again, this one crosses, so it will move over 1. This one crosses, so it will move over 1. And again, this one crosses, and this one crosses. So to get it really accurately, don't just throw it down anywhere. Make sure all the points cross as it should. It says the graph of y equals f of x has a turning point at minus 1, 1. That's this point here. Write down the coordinates of the turning point of y equals f of minus x plus 2. Well, the minus x means it's going to be a reflection in the y-axis, and then the plus 2 means it's going to move up 2. So reflection in the y-axis would go to here, and then to move up 2 would go to here. So the new turning point would be here at 1, 3. Question 19. 1 plus root 2 over 3 minus root 2 squared can be written in the form a plus b root 2. Find the values of a plus b. Now this is quite a difficult search question, because the first thing we need to do is we need to rationalise the bottom, rationalise the denominator, but we need to make sure we know what the denominator is first of all, so we need to expand that out. So we're going to start off with 1 plus root 2 over 3 minus root 2 times 3 minus root 2. Now, multiplying that out, again the top would not change, so we'd have 1 plus root 2 on the top. But multiplying that out, 3 times 3 is 9. 3 lots of minus root 2 would be minus 3 root 2s. Again, another minus 3 root 2s. And root 2 times root 2 would be plus 2. And if we simplify that through, that's 1 plus root 2 over 11 minus 6 root 2. Now, to rationalise the denominator, we need to use the difference of two squares. So we're going to multiply the top, sorry, that should be a plus sign, sorry. We're going to multiply the top and the bottom, which was 11, minus 6 root 2. We're going to multiply the top and the bottom by the opposite of the bottom. So we're going to multiply it by 11 plus 6 root 2. And we have to do the same to the top to keep that the same. So 11 plus 6 root 2. This is called using the difference of two squares, because when we expand these out, we'll end up with losing the square root signs there, losing the surds. So multiplying the top out, we'll have 11 plus 6 root 2 plus 11 root 2 plus 12. And on the bottom, when we expand that out, we'll have 121 plus 66 root 2s minus 66 root 2s. That's the whole point of doing this, these will cancel out, minus 72. Now, when we simplify all that through, we'll have 23 plus 17 root 2s on the top. And on the bottom, we'll just have 49. That was the whole point of doing the bottom bit, because it'll all just cancel out to be 49. So the value here then, A, is going to be 23 over 49. And B is going to be 17 over 49. So quite a difficult question because you end up with fractions, but you just need to simply expand the bottom and then use the difference of two squares like you would do with a more difficult search question anyway. Question 20. It says the diagram shows 3 right angled triangles prove that y equals 3/4 of n. Now y and n are separated by this triangle in the middle, so we need to work out some of these lengths. Now the biggest thing that we know how to work with right angled triangles are the hypotenuse. So I'm going to work out the hypotenuse of each of these. So I'm going to call this h1, I'm going to call this h2, I'm going to call this h3. I'm going to work out the hypotenuse of each. So to work out h1, we know that in a triangle, the opposite divided by the hypotenuse is the sin ratio. So we've got sin 30 is equal to the opposite, which is n, over the hypotenuse, which we'll call h1. So sin 30, we need to know the exact values of trig here. Sin 30 is 0.5. So 0.5 is equal to n over h1. And rearranging that, we'd have h1 equals n over 0.5, which equals 2 n's. So this here is 2 n's. I'm going to just split this up a little bit. So to work out h2, so this value here, we can use Pythagoras in this one because we've got on the big triangle we've got the hypotenuse and we've got this opposite here. So this is actually the base of that top triangle. So to work out h2, I'm going to use Pythagoras in this triangle here. So h2 squared would be equal to 2n squared minus n squared. So h2 is equal to the square root of 4n squared minus n squared, which is the square root of 3n squareds. So h2 would be equal to root 3n, square root in that. I'm now going to work out h3, so now we know that this is root 3n's. We can work out h3 because we've got this triangle here and we can start to put in y now. So h3, to work out that, again we're going to use the opposite and the hypotenuse. So we're going to use that sin 30 is equal to the opposite, which is y, divided by the hypotenuse, which is h3, the one that we're trying to work out. And again, sin 30 is 0.5, so we'd have 0.5 equals y over h3. And again, rearranging that, we have that h3 equals 2y, like we had in the first one. Now we're going to look at that middle triangle. So to try and get two equations that have both y and n in it, so we can get them what they are equal to each other, we can look at this middle triangle. So we've got that h3 here is equal to 2y's, and we've got the hypotenuse, this is root 3n's. So we've got the adjacent in this one, and we've got the hypotenuse. So this time we're going to be using cos. So we've got cos 30 is equal to the adjacent, which is 2y's, over the hypotenuse, which is root 3n's. Now cos 30, again we need to know our exact values here, is root 3 over 2, is equal to 2y over root 3n's. So multiply that out, that will give us, take the root 3n's up this side, we'd have root 3 times root 3n, all over, and if we might as well do this in one step, is equal to 2y times 2. So root 3 times root 3 is just 3, so we've got 3n is equal to 4y, and we can rearrange that, take the 4 down the other side, we've got 3/4 of n equals y, which is exactly what it asked us to work out.